Okay, continuing our example here, we're going to go ahead and do part B. It states to calculate the magnitude and the direction of the resultant, okay, of the resultant vector. So, remember when, say, I'm not going to put it in any certain direction, I'm just going to draw our resultant vector, okay, so I'm just going to pretend that this is it, okay. What we want to do is figure out what this magnitude, this final magnitude is, and what angle it is, okay. So this is going to be some angle, I'll call it phi, okay. So we now have the r sub x component and the r sub y component. I just realized that my b sub x is pointed in the negative direction, right? The x component is in the negative direction, so this should have been negative. So let me fix that real quick. Okay, so quickly recalculating this because I erased it. Our b sub x is going to be cosine, it's going to be b times cosine of beta. So b was 24.5 cosine of 54 degrees. And again, it's in the negative direction. So this is where we had that issue, okay? So this is going to give us 24.5 cosine of 54, okay? And so that's, again, 14.4. Let me do the AX quickly. It's going to be something similar. We have 41 times cosine of 29. That gives us 35.9. Okay, so we'll have 35.9 minus 14.4. And remember that our C direction, our C vector was just in the Y direction. So this is 0. Okay. So now our r sub x is 21.5. Okay? All right. So now we have our ry, which we did forget to, again, with the negative value. Okay, so this is just kind of a lesson to all of us, really, that we need to make sure that we are keeping our plus signs and minus signs straight when we're doing this. Okay, so we are in the negative y direction, so we're gonna, instead of that positive, we're gonna put a negative. Okay, and so now I wrote down our a sub y and b sub y again, and then we subtract our c value. Okay, and remember that is just the same as the magnitude of c, so that's 31. So we get 8.7. Okay. All right, so let's go back to our discussion of calculating our magnitude and direction of that resultant. So now we have both the components, okay, but we need to somehow put these together. So what we'll do is we'll say that r is equal to r sub x plus, or I'm sorry, r sub x squared plus r sub y squared. Okay, so r squared, which would be this value here, r squared equals r sub x squared plus r sub y squared. Okay, and this comes from the Pythagorean theorem. Okay, and if we want to solve for r, which is going to be our magnitude of the vector, we'll take the square root of that. Okay, so it's going to be rx squared plus ry squared, that whole thing square rooted. Okay, so we can plug our values in. So rx is 21.5 squared plus 8.7 squared. And we'll get, let's see, 21.5 squared plus 8.7 squared. We get 23.2. Okay. So this is R. Now we want to figure out this angle here. So what is the angle between the x-axis and our vector? And so what we'll do is we'll say, okay, we can calculate that by using a trig function. And we'll go, okay, so opposite over adjacent, that is tangent. So I'm going to say tan of phi is equal to r sub y over r sub x. And I'll solve for phi, or our angle. And that'll be tan inverse, or arctan, of r sub y, which is 8.7, over r sub x, which is 21.5. So let's go ahead and do that in our calculator. And we get an answer of 22.0 degrees. Okay. So what we have here is that our resultant vector has a magnitude of 23.2 at this phi angle, okay, of 22 degrees. Okay, so adding all three of these up, this is what we end up with. Okay. All right, so I know that that was a long question, but hopefully that was helpful. And let's go ahead and do the next one, which is going to be a little different. So this is going to be using the same information from the last equation, or the last example, but now we have a negative here. Okay, so in the last one, we found all of our components, right? Our a sub x, a sub y, blah, blah, blah. And what we'll do now is use those to find our new resultant. So r sub x and r sub y are now going to be ax minus bx plus cx. Whoops. And then ay minus by plus cy. Okay. So in this one, we had to physically change these two in order to account for which direction they were going in. Okay, so we'll have to do something similar. So in our x direction, we have c was 0, c sub x is 0, a sub x was positive, and b sub x is actually negative. So in this case, we'll have our a sub x and a negative b sub x magnitude, okay, plus 0, okay? So this is going to be just those two added. In this one, we still have a and b sub y are positive values, but c sub y is negative, so we'll have to put that in there. So a sub y minus b sub y minus c sub y. Okay? So we can use our values over here. We have 35.9 as a sub x plus b sub x, which is 14.4. So this gives us 50.3. Now we have a sub y, which is down here, 19.9, now we have a minus b sub y, which is 19.8, minus c sub y, which is 31. Whoops, minus 31. So now we have our r sub y is negative 30.9. Okay. So this is part A. Now for part B, we will do same thing. So we have r equals rx squared plus ry squared square rooted. So we have 50.3 squared plus negative 30.9 squared square rooted. And let me go ahead and put that into our calculator. So 50.3 squared plus negative 30.9 squared. We get 59.0. And our direction is going to be tan of that phi is equal to r sub y over r sub x, or phi is equal to tan inverse of r sub y over r sub x. So let's go ahead and plug in our values here. We have a negative 30.9 over 50.3, and we will get, let's plug that into our calculator, and don't forget that negative there. That's going to tell you a lot about the direction of the vector. Okay, so now we have negative 31.6 degrees. Okay, so this is our magnitude and our direction. Okay, and maybe some of you maybe don't remember, or maybe you weren't taught what that negative means if we're looking at a angle. Okay, so I'm going to quickly show you that. So if we're looking at the XY axis here, and we're given this angle, okay, typically when we're saying, okay, 45 degrees, for an example, okay, we'll say, okay, that's 45 degrees. Okay, but when we're looking at a negative value, we are going to actually move in the opposite direction. So typically we go counterclockwise when we're finding an angle, but now we're going to go clockwise, okay, when we have a negative value. So I'm going to say about right there would be our negative 31.6 degrees, okay? So again, when we're moving in, I can just make a note down here. If we're moving counterclockwise, our theta will be positive, our angle. If we're moving clockwise, our theta is negative, so our angle. Okay, hopefully that makes sense. Okay, and let's go ahead and move on. I'll only be able to start this, but then I'll continue in the next video. So we need to quickly talk about products of two vectors. So I said earlier, you can't just multiply two vectors. We call this something different. It's called taking the dot product of vectors, okay? And it's defined as so, A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between those two vectors. Okay, so phi is the angle between the two vectors that we're looking at. Okay, and here is an illustration of this. Okay, so we have vector A and vector B, and their angle between the two is that phi. Okay, I'll go ahead and continue this in the next video.